what's really nice with graphing is using the vertex form. And so this is standard form. Vertex form of a quadratic equation looks like this. Y equals a times x minus h squared plus k. These are really the same equation, it's just labeling things a little bit differently. If you FOILed this out, you distribute the a, you'll get exactly what this is. I mean, not with a, b, and c, but with the numbers. It's exactly the same thing, it's just how you write it. But when we're graphing, vertex form is great, because if you have it in this form, then whatever's here, h and k, will be your vertex. So you don't have to worry about what the vertex is, you know. And x equals h is your axis of symmetry. If you need a little reminder of this, right? Like the center point there is your vertex. And the axis of symmetry is like that imaginary line that cuts through the vertex. And they call that the axis of symmetry because you could fold that parabola over on itself. So it's symmetric about that line. And then you can also tell whether this opens up or down based on A. And remember that if A is positive, then your parabola should always open up. So if A is greater than 0, it opens up. And if A is less than 0, it opens down. So if it's already in this form, it's pretty easy to graph because you just graph the vertex, and you can use transformations to help you graph these. But you don't have to make a big XY chart. You don't have to mess with the vertex. But what if it's not in this form, right? And so that's what we're going to work on today. What if it's written like this, and we want to put it in vertex form first before we graph it? So on your homework today, I think the directions say to graph each quadratic, but some of them aren't in this form. So that's what we're going to focus on today. Okay. Any vague memories of this?
Yeah, actually, I was trying to say, I think we did this here already, but...
Yeah, I think it's algebra 2. Yeah. See why I get confused? And we do that in pre-calculus also. So I'm a hot mess of what I've taught or not. So write in vertex form, state the vertex and the axis of symmetry, and we're going to try to graph these too. If these are like terrible, a whole big number we might not graph, but I want to graph a few for you. I don't see lots of animal prints today too. I think those hard days. I don't have the animal prints. I have a rule, I don't like to buy things for
We didn't have the animal pictures of an animal on here.
I don't have anything with animals.
How do you do tomorrow?
Dress up for the job that you want.
So if I want to be a
So
teacher,
pretty much
put some glasses on and
just dress nice. Like I wouldn't count you for a teacher if you dress like that.
I'm going to be a teacher in the hood.
I feel like if you're gonna be like a famous athlete, just wear like a jersey.
No, I'm probably going to wear...
We decided in first hour that you could pretty much get counted for anything if you wanted to, depending on the job. Right? Like if you were,
dress matching, be like, oh, I'm gonna be like...
I'm going to work at a bank, or I'm going to work at a bank, or I'm going to... So you just got to be creative and think about what job you want, and then you can just dress how you want. Wear sweatpants and a sweatshirt and say you're just going to be a stay-at-home mom.
I'm gonna be some girls in polo. I'm thinking like...
I'm going to be a gym teacher.
Me too. I can wear shorts and t-shirt tomorrow.
You're gonna wear shorts and stuff.
I am. I might wear tall socks, but I'm wearing shorts. I was always jealous. I'm always jealous of gym teachers that they get to wear shorts. And I need the windsuit like him. Jumpsuit. I should wear that tomorrow. No, but anyway. Those were very popular in the 90s. Like, I'm pretty sure I might have owned one in the 90s. Alright, so here's the thing. This is not in vertex form. We want to make it in vertex form. So, This is a perfect square. This is not a perfect square. How do you take something that's not a perfect square and magically turn it into a perfect square? By how do you take something that's not a square and you complete it? Complete the square. That's my hint. Not a factor. Complete the square. So here's the thing. We only want to complete the square for the x's, so the 4 we kind of kick out to the end. So when I do this, I always group together the x squared and the minus 2x, and I leave a little spot because I'm going to complete the square, and then I kick that plus 4 out to the end, because you want something out there at the end, right? Because you want that k out there. And so we're not solving this, we're just trying to write it as complete the square. So you have to kind of think about the rules of complete the square a little bit. Step 1 is we still got to figure out what goes here. How do we do that?
Take half of that.
You take half of the middle number and square it. Super great when that's an even number. Because half of negative 2 is negative 1, and what's negative 1 squared? When we solve equations by completing the square, we add 1 here, and we also add it to the other side, right? Well, that's how we solve it. But we can't do this here because you can't add 1 to y. Like, y has to always stay y. So think about what we could do to keep this balanced. If I add 1 on the inside, what could I do on the same side that would undo that? You have to do the opposite out there. And that's the step that people get confused on. I always say, if it helps you, think about adding 1 over here with y and then subtract it back over. But the rule is, whatever you do on the inside, if you do the opposite on the outside, you haven't actually changed the value of it. Now we're just going to clean it up. And after we complete the square, you should be able to write this as a perfect square. And remember, it's always half of that middle number. So half of negative 2 is going to be x minus 1 squared. And 4 minus 1 is 3. Does that look like vertex form? What's my a in this problem? 1. There's a 1 out there. That's great. It means it's not stretched or shrunken any, right? Remember, that's a what? Shrunken. That's a word, right?
I don't think so.
I think so. Shrank. That does sound right.
Shrunken is definitely not a word.
Shrunk.
Shrunk. It's shrunk. Maybe it's just shrunk, not shrunken.
It's shrunk.
Who cares?
Oh, you got shrunk kids.
So what is the vertex of this?
How did that go from black?
Yeah, I don't know. Vertex.
That was on the eraser.
Vertex is H and K.
On a board.
Remember that this is always a minus sign in the formula. So when you take the inside number, it's the opposite of what's there, but the outside number, the sign comes with it, because it's x minus h and then plus k. And so then your axis of symmetry is the equation because of this. The formula is x minus h. So think about if you plug the negative 1 in there, wouldn't that become a plus sign? So you have to always take the opposite sign of what's in there because the formula has a negative sign in it already. Alright, so you just have to remember that the inside you take the opposite, outside you keep the same. The vertex is just x equals whatever h was, so x equals 1. So I just want to show you how easy this is to graph. This is why we teach vertex form. I know. How about that? That's better. That's straight. Oh, it's okay. When we graphed these before, remember we talked about that you're just kind of moving these around. If you're not doing a dilation where you're stretching or shrinking it, you're just taking that normal x squared graph that you should know what it looks like, and you're just moving it over. And you're moving it over this amount. You're moving it over right 1 and up 3. Or just use your vertex. Your vertex is now, instead of at 0, 0, it's over 1 and up 3. And if you want, you can make an XY chart every time. But remember, with a parabola, the normal parabola, you have 0, 0, and then what happens when you go over 1 on either side? You go up 1. So you can do the same thing here. It's not stretched or shrunk any. And you could go, the next one, if you go over 2, you go up 4, but I don't have that many on my graph, so I'm just going to wing it from here.
So because of the axis being the line, it just goes upward.
Because the vertex is at 1, 3, yes. The axis is always whatever that h is. Yes. You remember transformations? Like on the outside, it tells you how many it moves up, and on the inside, it's left or right. So this is actually up 3, right 1.
But how did you get it to just like where it was?
Oh, that's because A is 1, right? That means it's not stretched any. Think about remember the parent graph? Normally x squared, doesn't it look like this? Like when you plug in 1, you get 1. When you plug in 2, you get 4. So if there's no A value, or if A is 1, all you're doing is taking that graph and sliding it up 3 over 1, and it should be the exact same graph. That's how I knew to do plug 1 in. If you don't know that, if you don't know what your graphs look like, you got to make an XY chart. But the idea is, remember that big project we did of those graphs that you should know, the idea is you know what that graph looks like every time you go over 1, up 1 if it's not stretched, and you can just plug that in. Let's do another one. So it's just like the last one. It's nice, easy, even. So you start this one. Actually, I'll do the first step for you. Group these two together. Shove that plus 2 out there. See if you can complete the square before I do it, and I'll kind of walk around in a minute. Before we do the harder one. Right, half of 6 is 3, and 3 squared is 9. If you add 9 in here, you got to subtract 9 out there. So that's kind of the big step. There's not really much to show there, but it's a big step. Can you get the right number, and can you subtract it out there? There's really only one other step here, is it's just simplifying this. Remember that you're supposed to write this as a perfect square, and it's always going to be factoring that. It's always going to factor into a perfect square. Half of the middle number, x plus 3 squared. And watch your signs out here. 2 minus 9 is negative 7. I saw a few positive 7s out there. So now think about the vertex on this one. Taylor, on this one, because it's a plus 3, what's your vertex going to be? Negative 3, and then it's also going to be a negative 7. So you take the opposite sign on the inside, but you have to take the sign that's with outside. Is this one stretched or shrunk any? No, if there's nothing in front, I know, I don't know what to say. Compressed or, what do they say in the book? Compressed or stretched. Maybe I should say compressed instead of shrunk. So again, I know that when I graph this, I'm just going to go over 1 on each side and up 1. So when I graph this, I can say it's going to be, the vertex is at negative 3, negative 7. And when I go over 1, I'm going to go up 1. And I know it's going up because it's positive. And I can just sort of, I mean, I could do more, but that gives me a basic graph. Yes? Let's do a harder one. You have a question?
I always just like, maybe because like I don't know all the graphs that well, the functions, but the two dots, like,
Here?
just one more.
Over 1 up 1. If it's not, if it doesn't have a number out here besides 1, it's always going to be over 1 up 1. If you're not sure, you can pick the point right next to it. So if you're at -3, you can pick -2 and see what's happening. Like XY charts are never a bad thing. It's just you don't have to do them if you know what the graph looks like. Maybe I'll do more. Right. What's different about this one is there's a number in front of x squared, and you cannot complete the square if there's a number in front of x squared. If there was an equation there besides y, we could just divide by -3 and go on from there. But you can't divide y by -3. So what you got to do is think about how else could you get rid of that -3? You can't divide it out. Multiply it by what? I think you're on the right track. I think you're using the wrong word there. Could I factor it out of these two numbers? And again, remember the 10 gets shoved to the end, so don't stress about that 3 doesn't go into 10, because we don't care about the 10. We just care about these two. So if you see a number in front of x squared, you want to factor that out and then still kick that number at the end. And notice what happens when there's a number in front. You now have an a value, which means it is going to change the way that graph looks when we graph it. What will be left out of this? If I take the -3 out of that, that's x squared, and what's this become? Plus 6x, because negative and a negative. That's really about as hard as it gets. The only thing that could be worse would be if it was a decimal or a fraction. But there's an extra part here now with this number in front. Half of 6 is 3, and 3 squared is 9, so that's plus 9, right? And so if you add 9 here, you subtract 9 out here, but that's not balanced because, technically speaking, that's not just a 9 anymore. Do you agree that that 9 is technically multiplied by -3? So to keep it balanced, you have to multiply whatever you put out here by the number in front. I always do it like this, like whatever I put on the inside, I subtract on the outside, and then I multiply by the number in front. Some people just do the math in their head. They say 9 times -3 is -27, so I'm going to do +27 out here because that's how it would balance it out. I don't care which way you do it. I like it this way.
So it wouldn't change for the 9 inside the x squared plus 6x.
Right.
Why not?
Well, because it's technically 9 times -3, but we're not actually working it out. But if we did work it out, it would be -27. You with me on that? And so we have to think about that technically it's -27, so you have to balance it out here. But we want to keep it like this, or otherwise it won't be a perfect square. Okay? Is it ugly? -20. Yeah, let's maybe not graph it. Maybe I'll graph it. So this is going to be x plus 3 squared. Watch your math on this. I can tell you that every year I teach this in multiple classes, and I have people that do this. They say 10 minus 9 is 1, and 1 times -3 is -3. But order of operations, we should be multiplying first, so this would really be 10 plus 27 or plus 37. So Nathan says he doesn't want to graph this one because the vertex is -337. What does this negative sign tell me? If I was going to graph this. It's opening down. What does this 3 tell me? It's stretched by a factor of 3, which means you don't have to graph this one. Let me just graph it like very, very sketchy here. But -3, let's pretend right here is 37. And that would be my vertex. If there was just a 1 here, we know that if I went over 1, it's going down, I would go down 1, right? This 3 tells me go over 1 and down how many? Down 3, because it's stretched by a factor of 3. If that was a 7 there, you'd go over 1, down 7. That's the shortcut way of doing that without having to make an XY chart. If you are not sure, make an XY chart. You don't have to graph this, but it would be like over, down 3. Mine isn't terrible, but 37. Let's try one more, and I'll stop. Just for you to practice this. I think this is my last one. I could be lying. Because I like it to be a surprise. I just made these yesterday. You think I would remember? I don't know. A lot of not sleeping happened. I don't think my children are going to sleep. My Parker was up for an hour during the night last night. He's 6 years old. Why is he awake for an hour? From like 1 to 2. Because he has bad dreams, and then we try to put him back in his bed, and then he gets back up, and he says he heard a noise, and then I want to strangle him, and I yell at him, and then I tell him to lay on the floor next, on my, like, on the sleeping bag by the bed that I leave there for when he has bad dreams. And then he just stands up again and says, I heard a noise. And then during that hour, the baby woke up, so I got up with the baby, and I come back, and he's still awake. I don't know what to do with it. He's paranoid. Like, he hears things all the time. He's afraid. He won't brush his teeth in the bathroom by himself because he thinks there's a monster.
You should just leave him.
Like, it's a new phase. And the other day, he went to brush his teeth, and he said, I don't want to go in there. And I said, I hope a monster eats you. And then my husband got home, and he said, Mommy said she hoped a monster eats me. And I said, there is no monster! I fail as a parent, kids.
A little scary.
It's a new phase. My husband thinks he's jealous of the baby, but I don't know why that means he doesn't sleep. But
Because you're with the baby, you're in the kids all the time.
because the baby's up during the night, and oftentimes I just put the baby in bed with me because I just get so tired and I want to sleep, and he'll sleep in bed with me better than he's up here.
Best mom ever.
I've slept with both my kids like since they're babies, and if you're a sound sleeper, it's dangerous, but they move out of the way.
Yes, see you. I'm a sound saver, so that was not.
Like I promise. But now I've created monsters that don't sleep and stay up all night. Party.
Why don't you give him a nightlight? Does that work?
He has a nightlight. He has a dream light, and it's so cool. I didn't think dream lights would work, but it like lights up the whole ceiling. But I told him today maybe I'm gonna buy him a CD player and we can play music in his room, so when he wakes up during the night he doesn't hear noises. No, like soothing nighttime music that you play for babies.
And then a random scream in the background.
And chainsaw stuff.
Because I took the 2 out, right? If I take 2 out of these, that's right.
Yeah.
Like when I was up with the baby, I heard my husband yelling at Parker, and I come back in there and he said, Mom, while you were with Nolan, I heard a noise downstairs. And I said, no, you heard the toilet because it runs, like it's broken, and so every now and again it just acts like someone flushed it, but it really didn't flush it. And I was like, no, you heard the toilet running because it's broken. And he said, oh. I said, go to sleep. So then I'm all mad because he won't sleep, and so then I stay awake. And then I look down, and he's still awake, like 30 minutes later, just laying there with like his eyes open. And I said, shut your eyes! He should be. That's why I told him he has nothing to be scared of except for me. No, he's not scared of me at all.
See, when I was little, I was always terrified needing to go to my parents' room until I was still awake, because I was scared of something.
Yeah.
I always just laid in bed
So if I, 4 should go in here, so if I add 4 here, I subtract 4 here, but you gotta multiply by that 2, so you're really subtracting 8. Maybe we can graph this one, even though it's 13. Did you get that? I didn't walk around and check because I was telling you about my problems.
We like stories.
So that would be 2 times x minus 2 squared minus 13. I don't like that these two numbers are the same on the last two problems, because I feel like some of you are going to think they should always be the same, but they're not.
Probably when we were not. I didn't know.
Well, if I had another class, they would notice and they would tell me. Younger kids would say that. Kids are always like, so since that was the same, is that how it always works? That's what people always say to me. You guys are so advanced, I forgot that you're super cool. So this would be 2 negative 13. Is this one going to open up or open down? Up because it's positive. Is it stretched? Yeah, so let's actually make a graph here, even though it goes to 13, just so you can see this. The 37 one wasn't so great. I haven't done your homework, but if your homework has like an awful giant number, you don't have to graph it.
What would be considered awful giant? Yeah.
Like more than 20.
How about anything over like?
We're going to say 20. 20. Because I'll give you graph paper if you want it.
I was gonna say, I don't get purple lines when you over there.
I'll give you graph paper. I think my graph paper goes to 20. Oh, you think I would remember that I just put 13 dots on this and not count it again?
You're at negative 30.
What am I at?
The vertex is
Thanks. Sorry. I was all about the negative 13. I forgot I was at positive 2. Thanks. It happens sometimes. So we could make an XY chart. We could plug 0 in here. We could see what happens. But the idea is it's stretched by a factor of 2. So normally when you go over 1, you go up 1. But it's going by 2. So you go over 1 and you go up 2. You go over this way 1 and you go up 2. We went 1 more. Normally when you plug 2 into x squared, what do you get? 4. So if this one's stretched by a factor of 2, if you go over 2, you should go up twice 4, which would be up 8. 1, 2, 3, 4, 5, 6, 7, 8. And that would be the same. Again, you're not required to do that. You could make an XY chart and pick 2 numbers right next to your vertex. So if your vertex starts at 2, pick like 1 and 0. Plug them in and see what you get, and you'll always get the points. The idea is if you use transformations, it's a quick way to graph those. So really your homework today, like all of this, it's just a little bit of work to do. Tomorrow we're going to look at how to tell whether a graph has a max or min, and we're going to look at what if we didn't put it in vertex form. Could we graph it without it being such a pain as well? Maybe tomorrow. Will depend on what we get through with college registration. Ivy Tech. You okay with that? Look how nice my graph looks.
How do we find out if we want to take this spot? Like, what?
If you want to sign up for it,
Yeah, like,
you want to look at your scores that you have. You don't really want to get below a C and take a dual credit. You know what I'm saying? So like the 2 unit tests that we've had so far, if you've done about C work, then I would say you should sign up for sure. If you have failed those unit tests, you might say, I don't think I want to sign up because I'm pretty sure I'm not going to do it right. But you still have options. Like we still have 3 more tests, right? Unit 3, Unit 4, and the final exam. And if you do better on the final exam than you did on one unit test, it replaces one of the unit tests as well. So probably tomorrow she's going to say, if you pass the test and you qualify to sign up, she's going to say sign up. And then there'll be a drop date sometime in March that we decide if you want to join.
oh, okay, so we still can swap it if we want.
Yes.
Okay.
You want to grab this before you go?
Take our stuff.
Ferguson at school yesterday